Hi. So today I want to do a quick walkthrough of the event platform architecture that we've come up with. And I also wanted to show you the proof of concept that I've created based on the architecture. So very quickly, there's a lot more detail in the blueprint in the merge request that I'll link to this post. But basically, the current state is that we don't have a event bus or a event management platform really in GitLab, right? And so we've got various ways to publish events. So we've got webhooks and we've got event stores and we've got flow trigger events and a whole bunch of other ones which I'm not even begin to scratch the surface of. But we don't have a unified events platform. We don't have a layer where we can publish events to in a unified manner. And we don't have something that's scalable, right? So if you wanted to ever expose these events externally or allow people to consume these events externally as well, there's no sort of scalable platform layer that we have at the moment. And so that's where this new architecture comes in. So today, the way we do this is really using Sidekick and Rails. So the event platform is very, very much tied to Sidekick. And so what we want to do is move away from that. So in our attempt to modularize the GitLab monolith and to actually move to more modular services rather than having everything in one big code base and one big binary essentially, we want to be able to move away to we want to be able to move away to different services. And the events platform is going to enable that. It's not the only enabler, but it's going to be a big enabler. And the reason why we want to do this really is there's so many requirements around, especially around AI, which help us which need us to move to a more sort of flexible architecture for events. So today we have flow triggers based on a few events like mention, assignment, and reviewer, but we want and pipeline failures as well. But we want to expand to a lot more events, and not just that, we want to also expand to external events that are published by external publishers like Jira. For example, we want to issue to MR, where Jira could be the creator of the issue, where the customer may create the issue in Jira but want to create the MR in GitLab, and Duo could do that. And so that's really where this all comes in. So a core part of this new architecture is GitLab Relay, or what is today CAS, which is now being renamed to GitLab Relay. But essentially, what will happen is external publishers like Jira or Jenkins or whatever else will use the cloud event format to actually publish events to the GitLab Relay, and GitLab Relay would then basically send that message to an event bus. And now we'll have an abstraction layer within GitLab Relay, which will decide which message bus to use. For example, we'll have support for Redis because that's what customers have today. But then we can expand that support for NATs as we get NATs into dedicated and self-managed. We could have expand to support for NATs, which is a more sort of scalable message bus, right? And in the future, we could support other sort of cloud native message buses like GCP PubSub or something else, whatever customers have, right? And we could build on top of that abstraction layer. So basically, I should mention about cloud events. So cloud events is a generic specification for events, which is used, and it's a sort of mature CNCF project. And so the idea is that external publishers use that standardized format to publish to GitLab, and then GitLab publishes to the message bus. Now, the same format would be followed for internal publishers. So internal publishers would basically publish using the CAS gem today, which talks over gRPC to the actual CAS platform itself, and then CAS would publish to the message bus. So that's really the publish process. Now, because most of our consumers are all internal, right? So we would have GitLab Relay again acting as a consumer for all sorts of Sidekick jobs that need to be triggered. And so GitLab Relay would then write that to Redis, and it would do all the back pressure stuff. So make sure that Redis is not overwhelmed and Sidekick is not overwhelmed. And then it would write to Redis, which would then trigger off a Sidekick job, which would then trigger off all the workers. And to begin with, we could start with the flow trigger, which is one of the workers that we use here. But as you can see, this can be expanded quite a lot. So once we have these messages in a message bus, we could have a bunch of internal consumers, like an internal Go consumer or a Rust consumer or whatever else, that wants to read from this message bus and then do certain things. Like, for example, it may want to write to the data platform or write to ClickHouse or whatever else, right? And so we could have a number of services doing that. And then we could, in the future, also expand it to external consumers. So consumers which want to use a more scalable mechanism to actually consume from GitLab, so internal events from GitLab, for example. And so we could expand that, but I think that is a more complicated sort of proposition. We need to figure out, will that be a different SKU? How will consumers consume? Will they directly consume from the message pass? How will we handle authentication and stuff like that? So that needs a bit more thinking for certain. Okay, so this is the mechanism today. There's also authentication. So when external publishers publish, we'll use like a OAuth token or a PAT to sort of validate. And again, there is a dependency on GitLab here for CAS to actually validate the token. And similar to here, we'll use the CAS sort of JWT to actually publish to GitLab Relay here. So that's the authentication format. All right. So that's basically the architecture. I like to quickly show you this in action. So what I've done is I have created I have basically, let me show you first of all external publishing first. So I've created this little service that publishes using gRPC using the cloud events format. So let me just jump into the code there. So you can see that here we have this publishing example where I'm just publishing a cloud event message in the cloud event format using gRPC to CAS, right? So that's just the script. All it does is really just do that. And then I've got a consumer configuration here. This is the CAS consumer configuration that I've created. It basically reads from Redis and then starts off a Sidekick job. This is a Rails Sidekick job or Sidekick job that'll be triggered off. And I've written a very simple sort of basic logging job here, which basically just does some logging, right? It's just logging that cloud event that came through. So that's about it. So that is the job that's going to consume, and I'm going to just start monitoring the Sidekick log to see whether this actually came through. So I'm going to go ahead and trigger the external job. So this is something from Jira or another external system. I could publish that message, and if you see the message was published, and if I go to the log here, hopefully, we have to restart GDK. Okay, so let me scale this again, and then if I go ahead and publish, we should hopefully be able to see. This was working like a few seconds ago. We should hopefully be able to see the job come through. Ooh, okay, let's try this again. Maybe cast and yeah, now it's published. So now if I go here, you can see that event came through. So that this is the cloud event that came through and triggered off a Rails job, right? And so this way we can continue writing our code in Rails if we wanted to, and we support all these internal consumers. Then let's talk about internal publishers. So I can actually publish from Rails as well into this flexible event bus or event platform. So I'm starting Rails console. Then I'm going to just I'm going to set this up, and then I'm going to publish an event. So the event publish again follows the same cloud event format, and so I can just publish using cloud events. This is the event that I'm publishing, issues created, for example, internally, and I trigger that off, and that actually then goes and triggers the message. And if I go back here, you can see another event here came through, right? And so this is the entire mechanism, as we discussed, is basically external publishers are publishing to GitLab Relay using that gRPC endpoint that I showed you, and the internal publishers are using the CAS gem to basically publish. And then as we publish to the relay, it goes to the message bus, and then we've got that being picked up by a Sidekick job, and then the flow trigger worker here. So that's the entire thing. Quick next steps. So I want to deliver flow triggers using the same interface as this architecture. So we may not be able to get to this whole strategic architecture in the near future. But in Q1, we want to be able to deliver flow triggers. But what we'll do is we'll make sure that we use the same cloud events format to be able to publish to a common service. And that will still use event store to begin with. But then we can swap that out quickly with CAS. Figure out which team can deliver the strategic architecture. So we need to figure out, who's going to be able to deliver the architecture that we spoke about here, because this is impacts more than AI. It goes beyond AI to all of GitLab really. And then understanding how we can support external subscribers. Will that be a new SKU? How do we manage external subscribers? How do we manage authentication and tracking which messages have been consumed, handle their back pressure, etc. And so that's complexity that we can think about in the future. Okay, that's it from me. Thank you.